Welcome back. We're looking at factors affecting reaction rates and balancing some simple equations. So first up, let's just go through a couple of general factors here. Let me zoom in on this. Whoops, wrong direction. Some things that will change the speed of a reaction are temperature, which will usually increase the speed of reaction. Surface area will also usually increase the rate of a reaction if there's more surface area. So just like the solutions where we stirred, crushed, and heated to make it go faster, it will do the same thing for a chemical reaction. The other thing is concentration. If we increase the concentration of a reactant, the reaction should go faster because there's more reactant available in the same volume. And catalysts, which we looked at in class, are things that will speed up a reaction or make it occur maybe at a lower temperature. And the other important thing about a catalyst is that it's not consumed in the reaction. That's why it's usually written over the arrow instead of in front of the arrow. All right. So looking down here at number 8, we have a series of 5 reactions and we need to balance them. So we're going to do this by inspection, which means basically trial and error. And we can either set up little charts or just pick a spot and start balancing and see what effect it has. Given the limited amount of room, I'm just going to pick a spot and start balancing. Let me zoom in here a little bit. That's better. Starting at the first one, we have H2O plus O2 producing H2O2. Now, first thing I noticed right off the bat, oxygen is in 2 places on the left side. This could be a slight problem, especially because we have 2 plus 1 oxygens. That's 3 going in and just 2 coming out. Even numbers and odd numbers are not going to balance out until you make them both even. And the easiest way of doing that is by doubling something in the reaction. So I'm going to double this odd number over here. Now we have 2O plus 2O. That's 4 oxygens. So I'm going to put a 2 in front of that hydrogen peroxide. 2H2 is 4 hydrogens, 2H2 is 4 hydrogens. So the hydrogens are balanced. 2 O's plus 2 O's is 4 O's, 2 O's plus 2 O's is 4 O's. Those are balanced. Anything that has no coefficient yet gets a 1. Okay, next up we have sodium bromide reacts with calcium fluoride to produce sodium fluoride and calcium bromide. I'm going to pick bromide to start for no particular reason whatsoever because it doesn't really matter in this reaction. There are 2 coming out but only 1 going in, so I'm going to stick a 2 in front of sodium bromide. That changes my sodiums to 2, so I'm going to change sodium to 2 on the other side. 2 times 1 is 2. That changes my fluorine, coincidentally. 2 times 1 is 2, but look at this. It's already got 2 going in on this side, so I don't need to change anything. 1 calcium, 2 bromine, 2 bromine, so 1 and 1. All right, moving down, we have sulfuric acid reacts with sodium nitrite, ITE, not ATE, to produce nitrous acid and sodium sulfate. Now, the first thing to notice is that sulfate and nitrite are on both sides of the reaction, which means there's no need whatsoever to break this sulfur and oxygen up or this nitrogen and oxygen up. We're going to balance them as whole ions instead. Big chunks that cross the reaction without changing. So 1 sulfate goes in, 1 sulfate comes out. Good so far. 1 nitrate goes in, 1 nitrite goes in, 1 nitrite comes out. Still good. 2 hydrogens go in, 1 hydrogen comes out. That one's going to be a bit of a problem. So I have 2 hydrogens going in, but only 1 coming out. I have to fix this, so I'm going to stick a 2 in front of that. All right. Now, sodium is also a problem over here. I have 2 sodiums coming out, but just one sodium going in, so I'm going to stick a 2 in front of sodium nitrite. Coincidentally, that takes care of our nitrite problem. 2 go in, 2 come out, 2 hydrogens in, 2 hydrogens out, 1 sulfate, 2 sodiums, 2 sodiums. Balanced. Next reaction, silver oxide reacts to form silver and oxygen gas. Well, right off the bat, I notice that I have an even number of oxygens coming out, an odd number of oxygens going in, so let's double the odd number, 2. And let's take it from there. 2 times 1 oxygen is 2. I could leave a 1 there times 2, so the oxygens are taken care of. 2 times 2 silvers, 4. So I can stick a 4 in front of silver and a 1 in front of that O2. In this reaction, it doesn't really matter which one you leave for last, but I left silver for last because it's an element by itself. And really so is oxygen, even though it's partnered up. And those are the ones best left last in bigger reactions. Alright, last reaction, 8 sulfurs react with 2 oxygens to make SO3. Okay, S8 plus O2 reacts to produce SO3. I'm going to start with the 8 sulfurs. Whoops, slid off the screen there, sorry. So if I have 8 sulfurs going in and just 1 coming out, I need to put an 8 in front of that SO3. Alright, so now sulfurs balance. Let's look at oxygen. 8 times 3 oxygens is 24 oxygens. Well, over here, oxygen occurs by itself, which is nice, which means we won't have to affect any other elements by putting a coefficient in front of it. To get 24 oxygens, I need 12 oxygen molecules to go into the reaction. 12 times 2 is 24. And then I just put a 1 in front of that sulfur that's by itself. And we are balanced. Okay? Tune in for the next video for acids and bases.